Good morning, everyone. I am Pankaj. So today I'm going to explain about CLR1 parser. So let me share my screen here. So my topic is from automaton compiler design. Uh, it is CLR parser, canonical LR1 parser. So coming to the introduction of what is parsing, let us know about parsing. Parsing is checking if the input string followed the grammar rules or not. Like if you have a string, if the given grammar rules, we can construct that string or not. So you can see the visual example here. So with the given rules, can we construct the string like digit 3 into digit 4 plus digit 5, or else like they will give a string. We should check if we can construct that string using that rules. So you can see the real life analogy here. The cat sat on the mat is valid, like grammatically correct. Cat mat the on the sat the is very invalid, like it is not following the grammar rules. So coming to the LR parser, what is LR parser? L stands for left to right, and R stands for rightmost. In left to right, it scans the parser scans the input from left to right, reading one symbol at a time. Rightmost, this is the rightmost derivation in reverse order. Bottom. This is the pass key from leads to from bottom to up. So you can see the example here in real life analogy, like reading a sentence from words step by step. So we start with then individual words, move into phrases, and then combine into complete sentences. So it is the algorithm. Read the input symbol from left, shift the symbols on the stack, reduce when the grammar rule matches. Continue until the input accepted. Coming to the types of LRs, so we have LR0, SLR1, CLR1, LALR, and CLR. So our main focus is CLR1 as it is our topic. So why CLR is special? It is most powerful LR person, high accuracy in parsing, handles complex grammars, no conflicts or ambiguities. So coming to the power comparison is you can say the comparison CLR stands at the top. It is very powerful in LR parsers. Coming to what is CLR parser? CLR1 equals to is canonical LR1 parser. It uses lookahead, more precise than SLR parser, handles complex grammars. So we can see the comparison between the CLR and SLR. SLR parser uses the follow set for all the situation. CLR parser uses the specific lookahead for each situation. So we should know about follow and lookahead here. So you can see the example here. The sentence, if it rains, then seeing then tells us to expect a consequence. So not blindly following the next consequence, but by considering some inputs, we'll step forward. Isn't okay. You can uh, you can see in the next slide. So what is look ahead? Look ahead equals to next input symbol used for decision making. Based on that input symbol only, the decision is made. But in SLR, it is followed. Like whatever it comes, it blindly takes. Not like there is no decision making. So you can see here, reading the I will eat apple. If the next word is PIE, apple is the part of apple pie. If the next word is now, apple is an object. So we can see the decision is made by the next input here. So you can see how the look ahead works. Without look ahead, parser guesses many mistakes. With look ahead sailor, parser checks next symbols and make decisions. So look ahead is very important. That's why it is CLR is very powerful by using the look ahead. So coming to the next slide. So construction process steps to construct CLR parser. So first we have to augment the grammar. They will give grammar. We should augment the grammar and create the LR1 items and build the canonical collection. We construct the parsing table and perform parsing. So these are the nested processes. Coming to the example, grammar example, we have taken like S gives rise to CC and C gives rise to small c, and D. So where capital letters are non-terminals, we know that, and terminals are C, D, and start symbol is S. And production rules are number of production rules are 3. So what this grammar generates, like these are the possible strings generated by this grammar. So next step, coming to next step is augmented grammar. So in this we should add a new production, like this is the starting symbol, right? So we should add a new production S dash gives rise to S. Then it will become augmented grammar. See, we can see here down augmented grammar equals to S dash gives rise to S gives rise to C gives rise to small c, and small d. We can see here. This is the augmented grammar. We augment. Define the clear start condition, define the accept condition, parser knows when to stop. That's why you augment the grammar. Coming to LR1 items. What is an LR1 item? An item equals to production plus dot plus lookahead. So this is the structure of the LR1 item. So you can see the structure. A gives rise to alpha dot beta comma A. Where A is the lookahead, dot is the position maker, and production with dot is A gives rise to alpha dot B. So we can see the example also here. S gives rise to dot CC comma dollar. S is an internal dot before CC, and dollar is lookahead. Coming to the closure function. What is closure? Add all possible production when the dot is before a non-terminal. So we can see after seeing the example, you can understand easily. So if A gives rise to alpha dot B and B beta comma A is set, and B gives rise to gamma is a production, and add B gives rise to dot gamma comma B. With taking a look ahead, we will get the gamma also. So we should add all the possible. You can see here, based on our given example, dot S gives rise to S dash gives rise to dot S, right? And the dollar is the look ahead. So dot S produces CC. You can see here, example, CC here, S gives rise to CC, and C gives rise to C and D. So we can see that for S gives rise to dot CC comma dollar. We replace S with dot CC. C is non-terminal, so we add all the possible values of C, like what C produces. Here C produces small c, comma C or D with head, or C gives rise to dot D with C on. So coming to next slide, GOTO function. What is GOTO function? Move dot forward when the symbol is red. So we move the dot before, right? If A, here we can see the example. A gives rise to alpha dot capital X comma beta with lookahead A in set of I. Then GOTO of I comma X equals to closure of A gives rise to alpha X dot beta comma A. So we can see here with GOTO with X capital X, the dot move forward in the direction. So example, S gives rise to dot CC, GOTO on C gives S gives rise to C dot C dollar. Then we can apply the closure also. Coming to the canonical connections, what is canonical connection? Set of all LR1 items in states I0, I1, I2, and so on is called canonical items. How to build it? First, we have to start with I0. I0 means augmented grammar states with this representation, dot representation, LR representation is called I0 state. For each state, II and symbol X with GOTO of II comma X is new, add I0. Repeat until no new states. So we can see here, we are having the IO equals to, this is the first state, I0. S dash gives rise to S, and S gives rise to dot AA, and A gives rise to dot AA, and A gives rise to dot BA. Like in our example, in case of capital A, it is capital C, but same, everything is same. So with respect to S, it gives rise to S. S dash gives rise to S. It is I1, item. So in this, it is also called accept state. Coming to next, S gives rise to dot AA. It is a GOTO function with A. The dot moves forward. S gives rise to A dot A, and if it is A, right? So we should write all the possible uh, traits of A. A gives rise to dot A comma A, and A gives rise to dot B. And then with respect to A, we can move forward dot again in the iteration form. You can see here, and after A gives rise to dot A, and with both the function with A, we will get a I5. And then we can we have to write everything like that. Like there is no new steps. So you can see here, I naught with S gives rise to I1, I naught with A gives rise to I2, I2 with A gives rise to I5, and I2 with B gives rise to I4. Like you will get a state diagram like this. This is called canonical collection. Coming to the parsing table, it has two parts. First action part and go to table part. For coming to the action table for terminals, shift S, push and go to state S. Reduce R, apply rule R. Now accept users to parsing is done. Go to table for terminals, go to S users to go to state S. This is for reducing. So we can see here we should uh, write the table from this state diagram only. So we should here are the states 0, 1, 2, and C, D, S, C. So with the C where it is going, with D where it is going, with C where it is going, and with D where it is going, and with which step with which state it is accepting. Like that, we have to write everything. It is called a partial table. It is not complete table, but it is a partial table. Coming to the parsing example, so here we can see the input string CC and CCDD. So in step one, I would write like 0, in stack it will be 0, input CCDD in dollar. How to shift to 3? Like we will need C, right? So we'll perform an action shift to 3. So it will become 0C3, and the input will be deducted to C, D, D and dollar, and we need C again. So we should shift 3 again. So the stack will be 0, C3, C3. The input will become D, D, and dollar. And we need D, right? Non-terminal D, terminal D. So we should shift 4. So the stack becomes 0, C3, C3, and D4. We will end up having D only. So here it is reduced. So we should reduce C to D. And then it will become 0, stack becomes 0, C3, C3, and C8. Input will be D already. We should reduce C to small c and C. We are reducing. And 0, C3 becomes C8. And input will become D dollar. We should reduce C, small c, and capital C. So it will become 0, C2. The input is a D dollar only, and here it is a shift case. So we should shift 7. And 0C2 D7. The stack becomes like this, and there will be a dollar in the input, and reduce C gives rise to D. And after 0C2 C5 dollar reduce S gives rise to CC. And then the last step will get the management. So coming to the advantages of CLR, it is very powerful, most accurate, and it does not have no conflicts, and it handles the ambiguity. So coming to the disadvantages, it has large states and complexly built and uses more memory than the other. So trade-offs of it is power, complexity, and accuracy memory. Into the conclusion, CLR is most powerful LR parser. Uses one look ahead symbol for precision, handles complex grammars without conflicts. Construction involves 5 steps. CLR equals to accuracy plus power. using their compilers, what the complexity for different difficult grammars. So, thank you.